Naming and abstraction. In previous videos, we learned about the mechanics of programs: state, instructions, sequence, branches, and repetition. Today, we step back and look at how we manage complexity, how we make programs understandable, how we work with ideas instead of drowning in details. The key concepts are naming and abstraction. These are not about what a program does. They are about how we think about what a program does. Programs are complex. Even a simple program has many parts: variables, instructions, conditions, transitions. As programs grow, the number of parts increases: hundreds of values, thousands of instructions, millions of state transitions, millions of state transitions. No human can hold all these details in their mind at once. Our working memory is limited. We can track a few things at a time, not hundreds. So how do we manage? How do we write and understand complex programs? The answer is, we do not try to hold everything at once. We organize, we simplify, we focus on what matters and ignore what does not. Naming and abstraction are tools for this. They help us manage complexity by organizing information and hiding unnecessary details. What is a name? A name is a word that refers to something. When I say total, I am referring to a specific value. When I say counter, I am referring to another value. The name stands for the thing. Without names, we would have to describe everything in full detail every time. Instead of saying total, we would say the accumulated sum of all numbers processed so far. Instead of saying counter, we would say the number of iterations completed. Names let us refer to complex things with simple words. We define the name once, then we use the name everywhere. This is powerful. It makes programs shorter. It makes programs easier to read. It makes programs easier to think about. A well-chosen name communicates meaning. When you see total, you understand it is an accumulated sum. When you see counter, you understand it counts something. The name carries information. Names do more than give meaning. Names hide details. When you use a name, you do not need to know how the thing was computed. You do not need to know where it is stored. You do not need to know its history. You just use the name. Consider user age. When you use this name, you are referring to a number. You do not care if it was entered by the user, read from a database, or calculated from a birth date. You just know it is the user's age. The details are hidden behind the name. You can work with the concept without knowing the implementation. This is crucial for managing complexity. You cannot think about everything at once. But you can think about named concepts without thinking about their details. Names create a boundary. On one side, the details. On the other side, the simple concept. You work with the concept. You ignore the details unless you need them. Names are a form of something larger, abstraction. What is abstraction? Abstraction means ignoring irrelevant details. It means focusing on what matters and setting aside what does not. When you look at a map, you see roads and cities. You do not see every tree, every building, every person. The map is an abstraction. It shows what matters for navigation and hides everything else. When you drive a car, you use the steering wheel and pedals. You do not think about the engine's combustion cycles or the transmission's gear ratios. The controls are an abstraction. They let you drive without understanding every mechanical detail. Programs use abstraction everywhere. A name is an abstraction. It hides the details of a value. A concept like user is an abstraction. It hides all the data and behavior of a real person using the system. Abstraction is not about removing detail. The detail still exists. Abstraction is about organizing detail so you only see what you need. Abstractions exist at different levels. At the lowest level, you have raw details, individual bits in memory, specific machine instructions, exact memory addresses. At a higher level, you have values and operations, numbers, text, comparisons, arithmetic. You do not see the bits, you see meaningful data. At a higher level still, you have concepts, users, orders, messages, transactions. You do not see individual values. You see meaningful entities. Each level hides the details of the level below. Values hide bits. Concepts hide values. You work at the level you need. This is how we manage complexity. We do not think at all levels at once. We think at one level. When we need more detail, we go down a level. When we need more simplicity, we go up a level. Good programs are organized in clear levels. Each level has its own abstractions. Each level has its own names. Moving between levels is deliberate and controlled. Names matter. A good name makes code clear. A bad name makes code confusing. What makes a name good? A good name is accurate. It describes what the thing actually is. Total is good for a sum. Result is good for an output. X is usually bad because it says nothing. A good name is specific. User email address is better than data or string. The specific name tells you exactly what you have, is better than data or string. A good name is consistent. If you call something user in one place, call it user everywhere. Do not switch between user, person, and account for the same concept. Choosing names is an important skill. It is not an afterthought. It is part of designing the program. The names you choose shape how you and others think about the code. Abstraction is not just about code. Abstraction is a way of thinking. When you approach a problem, you do not start with every detail. You start with the big picture. What are the main concepts? What are the key relationships? Then you gradually add detail. You refine each concept. You fill in the specifics. This top-down approach uses abstraction. You work at a high level first, then descend to lower levels. Or you can work bottom-up. You understand the details first, then combine them into higher level concepts. Either way, you are moving between levels of abstraction. You are choosing what to focus on and what to ignore. This is how programmers think, not by holding everything in mind at once, but by working at appropriate levels, using abstraction to manage complexity. Abstraction helps us communicate. When explaining a program, you do not describe every instruction. You describe the key concepts. You use names. You work at a level the listener can understand. The program reads user data, validates it, and stores it in the database. That sentence uses abstractions, user data, validates database. Each word hides enormous detail, but the sentence communicates the essential idea. If you described every instruction, the explanation would be incomprehensible. Thousands of operations, millions of state changes, no one could follow it. Abstraction makes communication possible. It lets us talk about programs in terms of what they do, not how they do it. This is why naming matters. The names you choose becomes a vocabulary for talking about your program. Good names enable clear communication. Bad names cause confusion. Abstraction is powerful, but it has a cost. When you hide details, you cannot see them. Sometimes the hidden details matter. Sometimes you need to look beneath the abstraction. If a program is slow, the problem might be hidden in the details. The abstraction looks fine, but underneath, something is wrong. If a program behaves unexpectedly, the cause might be hidden. You see correct concepts, but the details do not match your expectations. This is why understanding levels of abstraction matters. You must be able to move between levels, work at a high level for clarity, dive into lower levels when needed. The goal is not to always work at the highest level. The goal is to work at the right level for the task. Sometimes that is high, sometimes that is low. Knowing when to switch is a skill. Let us summarize. Programs are complex. We cannot hold all details in mind at once. Names let us refer to things with simple words. Names give meaning and hide details. Abstraction means ignoring irrelevant details. It lets us focus on what matters. Abstractions exist at different levels. Higher levels hide the details of lower levels. Good names are accurate, specific, and consistent. They enable clear thinking and communication. Abstraction is a thinking tool. We work at appropriate levels, moving up for simplicity and down for detail. Naming and abstraction are how we manage complexity. They are how we make programs understandable,